Hello students, today we are doing section 1.3 and we're going to be talking about balance. So balancing is key to life, like our elephant here on our screen. We're going to be looking at solving equations with variables on both sides. So we're going to look at identity equations with infinitely many solutions or no solution. Looking at this balance here, or this scale, we know that one side has to equal the other in order to make it equal. So on the left side, I have 3 black pieces and 2 tan pieces. And on the right side, I have 3 black pieces and 2 tan pieces. So if we look at these, this is true because they're even to each other. The weights of them would be even, so this would be true. But looking at this one here, on the left we have 3 black pieces and 1 tan piece, and on the right we have 3 black pieces and 2 tan pieces. These are not equal. This is false. This would not be equal to one another because the right side has 1 extra piece. So looking at equations, we kind of think of the same thing. We look at that equal sign, that both sides have to be equal. This top left one, can this be true? 5 plus 2 equals 5 plus 2. Well, yeah, 7 equals 7. So yes, this is true. We know that 7 equals 7. But 5 plus 2 equals 5 plus 3. This would be 7 equals 8. And does 7 equal 8? No. So this one would be false because 7 does not equal 8. It's never going to equal 8. Okay, so looking at these bottom two here, x plus 2 equals x plus 2. Well, yes, this is true because no matter what x is, if you add 2 to it, you will get the same thing on both sides. But over here on the right, we have x plus 2 equals x plus 3. This one, x plus 2 would give you one answer and x plus 3 would give you a different answer. So this would be false because x is going to be the same number no matter what. So when we're looking here, we want to know what happens when we solve this equation. So this looks like equations that we've done in the past. 2m plus 7 plus m equals negative 14 plus 3m plus 21. So we want to combine like terms. So on the left side, I have 2m and m as like terms. So I know 2m plus m is 3m. I still have that plus 7 equals. On the right side, I have just a 3m there. There's no other m's on the right side. But I also have a negative 14 and a 21 that are like terms. So negative 14 plus 21 is 7. I still have that plus 3m there. So that negative 14 and 21 gave me this positive 7. Now I can work backwards and combine like terms. I need to move our m's all to one side. So you see that you have a 3m on the left, a 3m on the right. It does not matter which one you move. I'm going to move around here on the right. So minus 3m, minus 3m. Notice we know that 3m minus 3m is just 0. Those cancel. I'm left with just 7 equals 7. There's no m's left. So what happened to our variables? Well, they kind of disappeared. They canceled out. Okay, so they canceled out. Were you left with something that is true or false? Does 7 equal 7? Yes, so we were left with something that is true. Meaning we are left with an identity problem here. So we are left here with an identity problem where our variables canceled. We are not left with any variables. So it's an equation that is true for all values of an equation. So any number will work for the variables. So all real numbers or infinitely many solutions. So if we are left with something like this, where there's no variables left, and it's a true statement, our answer, we are going to say, is all solutions. So your answer will be all solutions, or you could say infinitely many solutions as well. Looking at the next one, we have 4x plus 7 minus x equals 10x plus 3x. So again, we're going to combine like terms. On the left, I see 4x minus x, which will give me a 3x, because 4x minus x. I still have plus 7 equals, there's no like terms on the right side, so there's nothing to combine. So 10 plus 3x over there. Let's combine like terms. So we are going to work backwards here, combine the x's, subtract this 3x. Notice my 3x's, they cancel again. 3x minus 3x cancels on both sides. So I'm left with 7 is equal to 10. So what happened to our variables? They canceled. So were you left with something that is true or false? In this case, we were left with something that is false, because 7 does not equal 10. This right here is not true. 7 does not equal 10. It's never going to equal 10. 10 is never going to equal 7. It's false. So therefore, our answer type that we are getting here is going to be no solution. So it's an equation that when solved, no value can make it true. No value works for the variable. So no matter what I plug in for those x values up there in the equation, nothing's going to make this equation true. So we would say no solution. So that's when we get a false, like 7 equals 10 or 3 equals 2, two different numbers equaling to each other that are not the same. So let's try a few. We have 2x plus 3x equals 5x plus 2. Let's combine our like terms. 2x and 3x is 5x. Bring down that plus 3 equals 5x plus 2. We want to combine like terms now and bring all the x's to one side. You can choose which x values you are going to move here. I'm going to move the right ones, 5x, and subtract those from both sides. Notice the 5x's cancel again because 5x minus 5x is just 0. And I'm left with 3 is equal to 2. So you have to ask yourself, does 3 equal 2? No, this is false. So therefore, our answer is no solution. So this is what you would put as your answer right here. No solution. Looking at the next one. Combine like terms. We have to distribute here. So I get 4y plus 12 plus y equals 12 plus 5y. Okay, combine like terms. I have a 4y and a y on both on the left side, so I have to combine those. That gives me 5y. I still have plus 12. Cannot forget about this plus 12 to bring down there. Nothing to combine on the right side. So now I have 5y plus 12 equals 12 plus 5y. Let's move all of our variables to one side. So I'm going to subtract this 5y. Notice these 5y's cancel, and I'm left with 12 equals 12. Well, does 12 equal 12? Is this a true statement? Yes, this is true because 12 equals 12. So we would say all solutions, or you could say infinite solutions. Either one of those, this one or that one, is your answer. All right, so looking at these, I want you to pause the video and give an example of an equation that has no solutions, one solutions, or infinitely many solutions. So give an example of what the answer would look like. So here, give an example of what the answer would look like. So would it be 7 equals 7 as the correct answer? Would it be, as a true statement, would it be 10 equals 2 as a wrong one, as a false one? What would these look like? So pause the video and have a go. All right, so an example that would be no solution is when it's false. So that would be like having 10 equals 2. If you had something else, that's fine, but as long as the two numbers on the either side do not equal each other, that's when you get no solution. One solution is the questions that we've kind of been doing. When you end up getting like x to equal 3, that's one solution. X is 3. Those are all the types of problems we have done up until this lesson. And infinitely many solutions would be when like 7 equals 7, or 2 equals 2, or 4 equals 4. That's when you get a true statement.